let's start with a little thought experiment, so to speak. Say I have this function, and I define the function as being the integral from 1 to x of 1 over t dt. And I say, okay, I'd like to graph this function. I'd like to figure out what this function is. So unfortunately, I can't just integrate this using the power rule. Try it and see what happens. So if you rewrote this as the integral from 1 to x of t to the negative 1 dt, and you use the power rule to integrate that, try that and see what you get. It doesn't work. It doesn't give us the result we're looking for. So I'm going to take a different approach. Okay. By the definition above, we know that if the integral of 1 over t dt is equal to our function, then the derivative of our function is equal to 1 over x. Alright, by the second fundamental theorem of calculus, if we take the derivative of this definite integral, we're going to get 1 over x. And that is dy dx. Okay, so what that tells us is that that is the slope of our function at any given x value is 1 over x. Right? So what I'm going to do is I'm going to take that information and I'm going to make what's called a slope field. We haven't seen these yet, but we're going to see them quite a bit. So this is kind of a good introduction to it as any. The slope field would look like this. This is obviously a computer generated slope field. But I could draw one by hand. It just wouldn't have as many tick marks on it. But each one of these little tick marks represents the slope of our function when I put the x value in 1 over x. So at x equals 1, we don't have any tick marks at exactly x equals 1, but the slope would be 1 over 1. And at x equals 2, all of these tick marks here would have a slope of 1/2, and these would all have a slope of 1/3, and so on. At 1/2, all these tick marks would show a slope of 2. So we can see that kind of gives us it's a really like a gradient field or a slope field that shows us the general shape that our graph is going to take. And we also know that f of 1, if we plug in x equals 1, we do the integral from 1 to 1, and no matter what this is, we don't have to know the antiderivative of this. We know if the lower and upper limits are the same, then that definite integral is equal to 0. Alright, so what that means is when x equals 1, our function value is 0. So that gives us a point at 1, 0. So that gives us a point right about there. So our function goes through that point and follows this slope field. So at least in a general sense, our graph f of x looks like that. So even though we couldn't really solve for it, we can still get a really good idea of what that function looks like, given the function defined as an integral and at least one point that we know on the graph. Hopefully this looks familiar. This looks a lot like natural log of x. All right. So what we've shown here is that this function f of x defined this way as the integral from 1 to x of 1 over t dt is the natural log of x. And then by the second fundamental theorem of calculus, that means that the derivative of the natural log of x is equal to 1 over x. And that's really going to lead us into 5.1 when we talk about the derivative of the natural log. We kind of start with this as a definition, but this is really a good way to kind of see that and make sense of why that is the case.